Greetings, everyone. I'm Patrick Veazie with NC State University. Today, we're going to be taking a deeper dive into rosemary culture and diagnostics. A lot of this work was in partnership with the CEA Herb Grant by Roberto Lopez out of Michigan State University. Today, we're going to be looking at rosemary, more of a spring transplant, or it can be finished out into a more finished form, like shown here in the bottom right. So for cultural management of spring transplants, we'll look at pH, EC, and dialing in that fertilizer rate, and a lot of the diagnostics that we've ran into this spring. So for cultural management, daytime temperatures between 67 and 75, and nighttime temperatures between 62 and 68, and maintaining a low relative humidity below 70% to reduce the occurrence of powdery mildew. And all of these recommendations are from the Ball Red Book if you'd like to know more about their cultural recommendations. So dialing in pH and EC, rosemary prefers a range of 5.8 to 6.2. And if substrate pH gets too high, it's very common to see intraveinal chlorosis due to lack of iron availability. So your EC range is shown here for your different methods, but a pour through of 1.3 to 2.0 is what we would recommend. Here at NC State, we've ran a handful of nitrogen rate studies on rosemary using 17,517 fertilizer, and you can see that drop in plant growth when the EC gets too high, as well as lack of growth when the EC is too low. Shown here is another EC rate study we ran with another cultivar, and similar results are shown with less growth at lower EC rates as well as high. So dialing it in between that 112 and 150 is kind of what we'd recommend. So shown here are the dry weight, EC, and pH via pour through for that study. We can see that that dry weight is maximized right at about 150 part per million. That's where we start to see that increase in EC, meaning that the plant isn't necessarily taking up all the fertilizer it's provided. Additionally, once you cross that fertility rate of about 150, we start to see that drop in pH occurring as well, which is something to monitor for spring transplants when they're small. So troubleshooting rosemary, there are quite a few problems that can be observed in rosemary transplants, shown here. Starting off with low EC, we'll often see stunted growth with pale green coloration on the lower foliage initially, and then entire plants. You can conduct an in-house EC analysis, such as the pour-through method, to determine if additional fertilization is needed, and especially for plugs, there's a lot of resources on e-GRO on how to conduct that. So high EC and over-fertilization, we'll see stunted plant growth with necrosis beginning on that leaf margin and spreading inward to the center of the leaf. Additionally, that stunted plant growth, such as shown here, with this 400 plant that was given 450 part per million versus a control plant of 150. Dry down, this is very common, especially being in smaller pots or cell packs. You see uniform tip burn across the foliage, but new growth will not exhibit the similar symptoms if it is dry down once that plant is newly irrigated. Powdery mildew, this is a very common problem with rosemary. This occurs on the upper side of the foliage, and you see this white fungal growth occurring. Reducing that relative humidity below 70% reduces a lot of the problems from occurring, such as shown here. Iron deficiency, intraveinal chlorosis is very common in rosemary in that new and emerging growth when that pH gets a little too high, such as greater than 6.5. So growers with high alkalinity should be aware of that new growth appearing chlorotic. So in summary, in the take home, rosemary prefers under 150 part per million constant feed to promote the plant growth, maintaining that optimal substrate pH. Preventing powdery mildew before infection spreads is very essential, and ensuring substrate has enough plant available water to support growth is essential as well to prevent that dry down from occurring and impact on the foliage. Once again, we'd like to thank the CEA Herb Grant for partial funding of these experiments. I'd like to thank everyone for attending.